lot more than is used to produce grain. As we grow wealthier, we grow much, much thirstier. Interestingly, France and Turkey are among the top 10 grain producers of the world. Now, there's going to be more pressure on them to produce that grain for that world demand. Ironically, the other top producers include Australia, China, India, the US Southwest, all of whom are facing severe water scarcity problems now, let alone when demand increases. But it's not just agriculture, energy. So the European Environment Agency estimates that 44% of the total freshwater withdrawal in Europe is for energy. Energy needs a lot of water. It doesn't necessarily consume it all, but it needs it for cooling and other processes. The US equivalent figure is 39%. The IEA estimates a 45% an increase in energy demand by 2020. This is without anything to do with climate change. This is just the demands of our growing world. Think of all those developing countries who have extreme energy poverty today and the challenges that they'll face in terms of that water resource base if a certain type of energy is preferred for the growth model. This makes energy policy as much about water as it does about carbon, I would suggest. For example, in terms of consumption of water, about 3 meters cubed per megawatt hour is needed for coal, about the same for nuclear, about 6.5 meters cubed per megawatt hour for oil. Solar and wind, obviously zero. Hydro, about 17 meters cubed per megawatt hour. Most of that is evaporated from the reservoirs. Up to 360 meters cubed per megawatt hour for first generation irrigated biofuels. Hold that thought of the EC target for 20% of fuel energy mix from biofuels by 2020 and just overlay that onto some of the water statistics I just gave you. In fact, if irrigated biofuels first generation we're going to provide up to 25% of global energy supply, that would require 75% of current freshwater withdrawals globally to meet that demand. Hydropower is an interesting one, very important for this region. 43% of energy from Southeast Europe is from hydropower, 75% in Albania and Montenegro. How are we going to provide even more energy if we're kind of maxed out on our hydro when we compare that to those figures for agriculture for this part of the world? Another twist in this energy-water nexus is, of course, water itself is a huge consumer of electricity. One of the biggest factor prices in any kind of water utilities budget is for electricity. 80% of the costs of the US water industry are estimated to be spent on electricity. So as water demands grow, so will demands for energy. It goes both ways. This means that, again, energy policy has to also be a water policy in order to manage these competing demands. Cities growing fast. UN Habitats estimate that 60% of the world's population will live in cities by 2030. If any of you have got any sense of the history of the world's population, how we live and what that means, that's a hugely significant number. Just think, most of you are probably city dwellers. Where you get your energy from just comes on the light. Where you get your food from, probably from supermarkets, probably processed food, probably a degree of meat product in there. Work that back through the chain in terms of the demand that that creates on water resources. It's going to be very large indeed. Interestingly enough, 60% is also the percentage of Chinese cities, 639, which are already facing chronic water and wastewater shortages already. Athens got 3.2 million people. It's a third of the population of Greece. The larger urban zone of Athens has 5 million people, seventh most populous area in Europe. Ankara, 3.9 million people, grew by 1.4 million people since 1990, had 290,000 people in 1950. Istanbul, fourth largest city in the world, 12.6 million people. Population tripled 1980 to 2005. Interesting, because they all have very, very old assets in terms of their water supply, even Ankara. I mean, you're talking, on average, about 40% of water in cities is lost through leakage. US EPA reckons for US cities $68 billion required just to maintain, just to keep the status quo of the current asset base in US cities. Business as usual will see a worldwide city increase in demand of 70% for fresh water, 21% in Europe. So the city footprint, let alone the energy footprint, let alone the agricultural footprint, is increasing in its demand for water at an exponential rate. I've put a little box here called security, just to think about a couple of issues building on what I just mentioned in terms of city. In 2008, Istanbul had just 28% of its reservoir left. Ankara had just 1% of its reservoir left. Same year, Atlanta, Georgia had just 87 days left of water. Raleigh, North Carolina, 97. For Californians, the emergency coping measures to do with not necessarily drought, but just an inefficient water management policy, costing taxpayers $1.6 billion a year. It's about 2% of the state budget. About the same for Australia, slightly less, just over 1.5% of its GDP is being eaten up by emergency measures to water shortages. You all remember the pictures of Barcelona and the tankers, 22 million euros for 6 tankers of water. So, there are some fairly important issues to do with global water and water for this region before we even begin to think about climate change. Here's just some images. The top left-hand corner is satellite imagery of this part of the world for 2000. The blue is farmland, which is totally dried out. That wasn't necessarily a bad drought year. 2003 was obviously the worst year. Top right is a place called Lake Tuz in Turkey. This is probably a sort of Turkish equivalent of the Aral Sea. 85% of it has been drained over the last 90 years. It was the second largest lake in Turkey. It's going to be gone by 2015. You can see the sort of salination and dust from all of that. It's gone from 216,000 hectares down to less than 30,000 hectares. The bottom left-hand corner, that's Cyprus. That's a key river in Cyprus. In Cyprus, the demand is for 100 million meters cubed of water every year. The availability for the last 3 years was 24, 39, and 19 million cubic meters of water. Water is being shipped in from Greece to Cyprus. In Crete, the aquifer has dropped 15 meters since 2005. Bottom right-hand corner is a power station in Turkey. It's indicative of the kind of coal-fired power stations which require water for its cooling and which face